Yes, welcome back Form Force for our continuation on the electrochemical cells. Today we want to look at the magnesium copper electrochemical cell. And we have a diagram here of the magnesium copper electrochemical cell. Now on the left hand side we have magnesium electrode dipped into a solution of magnesium sulfate. On the right hand side we have copper, this one should be copper, dipped into a solution of copper 2 sulfate. From here you realize that the one which is more reactive is drawn on the left, the one which is less reactive is drawn on the right. So on the magnesium electrode, we have the magnesium solid forming magnesium ions by losing electrons. So these electrons will move from magnesium, which is more reactive, to copper electrode, which is less reactive. So this one is the movement of electrons. Now, in this solution, we have copper 2 ions. And in this solution, we have magnesium ions and also sulfates ions. Here we also have sulfates ions. Now, coming here, this solid, a metal cannot gain electrons. So what will happen? It is this copper 2 that will gain electrons to form copper. So the electrons from magnesium moves to the copper electrode, reaching the surface of copper electrode, they'll be picked up by the copper 2 ions. Picked up by the copper 2 ions. Again, loss of electron occurs on magnesium electrode, and loss of electron is called oxidation process. Gain of electron is called reduction process. So, because we have more electrons on this magnesium electrode, then it is the one that is negatively charged. Because we have fewer electrons here on copper electrode, then it is one which will be positively charged. The electrode where oxidation takes place is the anode. So this side we have the anode. The anode is the magnesium electrode. The one where reduction takes place is the cathode. So the cathode is the copper electrode. If we are asked to write the overall equation, then what we are going to do is that we will combine the two equations. We take magnesium to form magnesium 2, which is the oxidation equation. We combine, so this one is the oxidation process. We combine with the what? Reduction process, where copper gains 2 electrons to form copper 2, gain 2 electrons to form copper. This one is the reduction equation. Then we add them the way we did last time. We take the reactants, magnesium, copper 2, and 2 electrons. We put together magnesium, copper 2, and 2 electrons. Then we also take the products, magnesium ion, 2 electrons, copper. Magnesium ions, 2 electrons, then copper. We remove the 2 electrons which are common on both sides. We remain with magnesium solid reacting with copper 2 ions to give magnesium 2 ions plus copper solid. This one is the overall cell reaction. Overall cell reaction. So this one is our second example. Now I want to compare an electrochemical cell with electrolytic cell. I want to compare an electrochemical cell with electrolytic cell. Before that, I want us to note some 2 points here. Now, 1, the anode here, before I move the anodes, let me do away with this. Yes. So I want to draw an electrolytic cell. And my electrolytic cell will be this way. Yes. So this one is our battery. Now, when we close the circuit, when we complete the circuit by closing the switch, this one is our negative terminal. The long one is our positive terminal of the battery. Anything connected to the positive terminal becomes positively charged. Anything connected to the negative terminal becomes negatively charged. Let's say this is copper 2 chloride molten. So what will happen? Inside here we have copper 2 ions and chloride ions. So if you compare the 2 cells, electrochemical cell, electrolytic cell, the setup for electrolysis which you learned in Form 2, you'll realize that 1, here the anode, the one which is connected to the positive, is the anode. So the anode is positively charged. The anode is positively charged here because it is connected to the positive terminal of the battery. Then, this one here, which is negative, is the cathode. Cathode. And the cathode is negative. Why? Because it is connected to the negative terminal of the battery. So compare the anode here in the electrochemical cell and the anode in the electrolytic cell. The anode in the electrochemical cell is negatively charged. The anode in the electrolytic cell is positively charged. Why? Because it is connected to the positive terminal. The anode in the electrochemical cell is negatively charged because it has more electrons. The cathode in the electrochemical cell is positively charged because it has a large number of positive ions. The cathode in the electrolytic cell is negatively charged because it is connected to the negative terminal of the battery. Let us compare the reactions. At the anode, the copper 2, at the anode, the chloride ions will be attracted to the anode because they are negatively charged. The copper 2 will migrate to the cathode because they are positively charged. A positive attract a negative, and a negative attract a positive. Now, at the anode, the chloride ions will lose electrons to form chlorine gas. Loss of electron is oxidation. The electrons will move from the anode to the cathode. When they reach the cathode, they will find copper 2 waiting here. So copper 2 will gain the electrons to form copper. Gain of electron is reduction. So, for the electrochemical cell, oxidation occurs at the anode. The same for the electrolytic cell, that is a similarity. Oxidation also occurs at the anode. For the electrolytic cell, reduction occurs at the cathode. For the electrolytic cell, the reduction process occurs at the cathode. Those are similarities. So, this one is an electrolytic cell, this one is electrochemical cell. When we come to those points, the first one, the anode is the electrode where oxidation. The anode is the electrode where oxidation or release of electrons takes place. The cathode is the electrode where reduction or gain of electron takes place. So that is how you are supposed to define anode and cathode as from today. Forget the one that you are given in Form 2. And then the anode is negative, is the negative electrode because it has an excess of electrons. The cathode is the positive electrode because it has an excess of positive ions. Very important point there. Then in electrolytic cells, the anode is positive because it is connected to the positive terminal of the battery. Then while the cathode is negative because it is connected to the negative terminal of the battery. We have explained that down here. Then, another one, in electrolytic cells, the flow of electrical energy results into chemical reactions. In electrolytic cell here, for reactions to take place, you must have a battery source of electricity. Flow of electricity will cause chemical reactions to occur. While in the electrochemical cells, the chemical reactions at the two electrodes result in the flow of electric current. So here, for you to record any voltage up here, for any voltage to be recorded here, reactions must take place at the two half cells. Reactions giving electrical energy. Here, electrical energy giving chemical reactions. Remember, electrochemistry is the study of the relationship between electrical energy and chemical reactions, where in some cases chemical reactions give electrical energy, while in other cases electrical energy will give chemical reactions. So next time we meet, we'll look at the functions of the salt bridge. The functions of the salt bridge. That one brings us to the end of the two examples of electrochemical cell. The zinc copper electrochemical cell and the magnesium copper electrochemical cell. Let us meet next time in the next video.